So welcome to SmartQA Musings on high performance QA. And in this discussion, we probably would look at two interesting concepts and a ratio between them, which is called the power and the weight, and how the power and weight ratio matter to high performance QA. So what does it take to deliver high performance? Is it just power? That's a question that I'm posing. So high performance is doing something much better, much faster, more efficiently, and so on. Is it just about more power? And does higher power, does it imply speedy work, higher speed? And therefore, is high performance all about speed? That's the question that I'm leaving you with. We'll answer it in the course of the next few minutes. So let's take a look at it in a slightly different context. Let's ask ourselves, what are we trying to accomplish? We're trying to accomplish a piece of work which is heavy. And to accomplish this piece of work, we need some power. So what do we mean by that statement? We mean by that statement is, okay, I've got some weight to push. I have physical or engine power, and I push this weight. And if I can go faster, it means my performance is improved. If I can move a heavier load, it means my performance is much better. If I'm able to take the same weight or higher weight and still climb uphill, that means my power is my performance is significantly improved. So ultimately, when we talk about high performance, it's not just speed, it's also about how heavy or how much of work that we're able to accomplish in the same amount of time, hopefully, and how we are able to take in much more higher complexity, more larger work, more complicated ones, which is really, in some sense, climbing uphill, right? And therefore, the question that we want to ask is it just about raw power to accomplish faster, heavier, and uphill? And the answer is, well, I guess if you want to be climbing uphill, it seems like gravity is important, isn't it? So if I'm pushing a load, so maybe weight matters, right? So if it is lesser load, I should be able to go faster, certainly climb uphill faster. Those seem to matter. So it's not just about raw power, right? It looks like there is a component of weight, and that's what we're going to establish. So now let's take a look at two examples. We'll start with cyclists and then later move on to an insect. And start with the cyclist. Well, as I'm a cyclist, of course, I'm not a racer, but I really enjoy watching Tour de France for sure. And I'm quite sure some of you do too. And if you see a pro cyclist, casually climbing at extraordinarily high speed in the Alps, for example, as part of Tour de France, it amazes me. How the heck do they do that? Now, they care seriously about weight. Their cycles are obviously very light, and those guys are absolutely skinny. Why do they do that? Why do they worry about it? They worry about the fact that, despite the aerodynamics, which is basically wind and how we relate to wind, is one of the biggest determinant, because there is a lot of flat surface and they really need to cut through air because air offers resistance, and the higher the speed, the more the resistance, right? But not to forget the fact gravity also pulls you down, especially during climbs. So we need to worry about two aspects. We need to worry about high speed during flats and being able to maintain or even accelerate when we are going uphill. So one is probably seriously determined on the power that we generate on the flats. And the second one has a more significant bearing on the weight of the rider and the cycle, because that is important for climbs, because I want lesser, so to speak, weight because of gravity being there. So what do I do and how can I accomplish this? One, I can upgrade to better components. I can buy a much lighter bike, maybe all carbon, for example. But then it costs. Those bikes cost about $10,000 and so on. It is expensive, but yeah, it gives you fantastic performance because the components are good in the build and in the parts and so on. The second thing is instead of a cyclist being an 80 kg, if the guy is, let's say, 45 or 50 kg, then it simply means he doesn't have any extra ounce of flesh. He just has muscle and no excess weight. And therefore, it's a far more economical way to achieve the same end, to climbing faster. So as you can see, we're discussing two things here. We're discussing the notion of power, and we are discussing the notion of climb, and the power is enabled by the engine, in this case the human, and the second power is generated because of fantastic components, are aided by fantastic components, and of course the weight, which is truly my individual weight and the cycling weight. And to put it in the context, this is the picture which talks about, hey, which matters where, and that's what we talked about. If the terrain is flat, then it's absolute power that matters, right? So as a cyclist, if I am able to generate an enormous amount of wattage because of my, let's say, my internal strength, then really I can go fast. And that's why you will find them going at about averaging 40, 45 kilometers per hour for a long duration of time. But when it comes to climbs, it is important to understand that it is not just power. Weight matters. So the power to weight ratio becomes important. So when we do a climb, the ratio becomes important. When it's absolutely flat, power seems to outweigh the weight, so to speak, right? Of course, at both the points, weight is important. So keep this idea in mind of being in the flat and doing the climb. Keep this idea when we get to in a minute when we talk about it from the context of testing. And really, if you watch any of these races, you'll find that the best climbers are those who are both lightweight and strong. And I don't think it's difficult to appreciate that, because I really have the best of the power to weight ratio, so to speak. Let's shift to an insect. We all know about grasshoppers, right? And grasshoppers are pretty interesting. They can really jump very high. Ticks also jump very high. Now, it's so lightweight and its legs are so spindly. How in the name of God it's able to jump so high? And the interesting article that I bumped across, which is listed here, talks about the idea called the catapult. And it says they use a catapult. And he proposes a principle called the catapult principle. So we know catapults are basically tools that help us throw things farther, which otherwise we could not have done, and we just doing raw muscle power, right? So in a way, jumping is like throwing yourself using legs. And we all know bow and arrow kind of uses the principle of a catapult. So what do we do in catapult? What's the principle? We pull the string with a certain amount, using a certain amount of power that we have, pull it all the way down slowly, and then release it. And then bang, it hits the arrow, and then the arrow flies really far. So it's not about speed here. It is about the power which is slowly, the torque that is slowly generated and then held and then released. And when you release, that enormous amount of torque translates into a massive amount of power. And that's what helps us, to do this stuff. And that's a principle. So keep the idea of catapult principle. We'll revisit it in the context of test and hopefully connect to it in the last slide. Now let's apply these ideas to testing. So let's ask two questions here. What is power in the context of testing? And then later move on to what is weight in the context of testing. So let's talk about the first one. Power is something that we generate using what? That helps us to get a job done. And how do we generate it? Using a combination of the organizational processes, which in a way helps us to figure out what activities to be done by who and when. And that's one part of the power generation. Second part is my individual power generation as a practice of how I apply interesting techniques. So I generate a certain amount of intellectual power. This is some kind of an organizational power. The third one is this in terms of the aids that are given, that we use. Could be some technology and tools which assist us in doing these activities, right? So we use a variety of tools, some for execution, some for management, and so on and so forth in the context of testing. So there is an organizational context to the power from process, there is an individual context to the power from a personal practice, and there is, of course, the technology component from the tools, and therefore the power can be put in as a simple equation as a function of P1, which is process, P2, which is practice, and T, which represents tools or technology. Now let's shift gears to saying what is weight in the context of testing. The weight is basically the load that we want to lift or move or whatever. And this can be signified as what am I going to test, and what am I going to retest. That's the work that I have to do. And what I do is I test certain entities or retest certain entities. So what do I mean by entity? I'm testing some entity. It could be a screen, it could be a feature, it could be an end-to-end flow, and so on. And remember, we're not just testing an entity for its functionality. We're probably also using it to validate other attributes. So I'm kind of saying, hey, attributes are really a set of various things, which could be functionality, usability, reliability, performance, and security, and so on. Now, when we talk about entities, what kind of entities are we talking about? One is, the smaller ones to the bigger ones. But in a general sense, we're also thinking of entities as brand new ones, new features, or enhanced ones, which is enhancing an existing stuff, maybe enhancing a feature. Or sometimes it's fixed. It's not new, neither it's enhanced. It's unfortunately an issue that we found, so we actually fix. So these are entities of, which are new, enhanced, fixed. But by the way, when we actually enhance or fix or add new, we all know that we are worried about impacting others. So we also have entities that are not modified, that are not fixed, that are not new, but they may be impacted. So there are possibly, when we say entities, we are talking about a set of, hey, new entities, enhanced entities. I'm trying to put it as a set. So I'm kind of saying, hey, here is a set of entities, here is a set of attributes. And what is test? Test is basically test entities that are new and enhanced for A. And A, what is it? It's a set of functionality, usability. Consider whatever attributes that matter. And retest entities, for what? It's a set of fixed and impacted for also the A. I guess you get the idea. I'm just trying to put it in a simple mathematical equation to give us some logical way of dealing with this. And let me picturize this a little bit. Continuing on the fact that, hey, I have got various entities, and I said test entities that are new and enhanced for A is one part of the weight. So we have to picturize it and say, hey, in this particular release, I have got at this particular build, let's say I've got 8 new entities that I'm building. Oops, sorry. And I have maybe got 5 entities which are being enhanced. And let's say there are 3 entities denoted by F1, F2, F3, which are being fixed. So I'm saying, I need to test what? I need to test the new. I need to test the enhanced, right? And what do we need to do? We need to test the new for whatever attributes that matter. Most often it's functionality, but certainly we might also have to test certain things for non-functional aspects as applicable too. And the same thing holds good. Do I test a fix? Yeah, I would rather put it in the context of refix, but I'll come there. Retest, I'll come there. And then what do? We certainly retest those impacted items because of the new ones, which I've denoted as I1 to I8, just for easiness. It may not always be 8 to 8, obviously. Or we may have to test some other entities which are I9 to I13, which could be impacted because of some enhanced. And because of certain fixes, maybe there are other entities that may have to. So I'm kind of giving a simple notion of there are these entities that you can see here in the second part of the row, which is colored differently as a retest, again for the same stuff. So just to put the context and saying this is the amount of work that we need to do if we were to do it thoroughly. Of course, we will optimize, and of course, we will also make certain choices because you may not have appropriate amount of effort or time, but that's an intelligent choice that we make. But this is just how I would picturize. So therefore, if I were to put it into a simple formula, I would say weight is again a function of retest and test. And if I were to kind of complicate a little bit, I put it as a nicer, simpler formula. It's basically 2 sets. The first set is a Cartesian set of what is new and enhanced cross A, what is fixed and impacted cross A, and therefore we've got 2 sets, which first set relates to test, the second test relates to retest, and therefore that is an indicator of weight. We had a formula for, in some sense for power. We had we have kind of a formula for weight to give us a better perspective of what it means. Now, let's examine this ratio and ask what it means. Now, ultimately, we said power comes from process and practice and tools. And if you kind of think a little, what does it mean? Processes give us certain sense of clarity, in terms of being consistent so that we can be clear what to do, so that I know I am supposed to do this at this time, you are supposed to do this at this time, and therefore there is certain amount of consistency and clarity that is due to the process. Whereas the individual practice, how my capabilities, my mindset, the techniques that I use, the practice, things that I do are really help me to be fundamentally effective. That means I do good job. Whereas the tools that I use help me to accelerate the entire process or accelerate the entire practice. And therefore, tools help me to be speedy. Now, when it comes to weight, and you look at those equations that we talked about, which is a function of test and retest, test sometimes is heavy. What do I mean? It's a complex feature or a complex flow, or it's a very complex attribute to validate. So I'm just saying that's more like heavy. Whereas the retest is largely voluminous. It's just that, I've got to test X number of features or run Y number of regression scenarios or whatever. So it's just largely voluminous. Now put this in context. Our power to weight ratio, so to speak, needs to be able to do two things. It must do heavy lifting effectively, and it must process large volumes speedily. I hope you get the connection between clear, effective, speedy, heavy, volume in the context of power and weight. I'm trying to kind of collapse all of them here into this statement. Now, given this, and I want you to connect this back so that we appreciate where we are getting. So we remember when we talked about cycling, we said, hey, there are flats and climbs. And we said we want speedy ride on flats and we want high torque on climb. So if you can watch carefully here, tools are useful here because it's raw power. So we want to do speedily. So I want to just cover a large volume of ground very quickly. And that, if you go back to that, is here. Retest. Certainly very valuable. But I need a high torque during the climb. And that is where my individual abilities of techniques and organizational context of certain consistency and clarity are terribly key, because I can't generate high torque. And that is what is needed to do heavy lifting, right? So where am I going with this conversation of power to weight? I'm just trying to set the context that, look, it takes many things to be able to accomplish this. It's not just about tools or automation, less largely we would like to believe, and therefore say, look, if I can adopt a nice tool and wow, everything will become brilliant. We'll just get into the next level of high performance. It doesn't happen that way. So power, to summarize, remember, power is important, but weight matters too. And power really comes from individual capabilities, organization systems, tools, and technology. And weight lightens with less rework. I'm putting in a new word here called rework, where I'm saying, look, if I'm not effective, I end up having more fixes, I end up having more volume, and therefore adding more power is not going to help. Making more automated scripts may not help. Right? And therefore, I need to be worrisome about the fact that I want to do really good work. And therefore, weight reduces with less rework, which really is a corollary of good work, but severely becomes heavy if I have got to do a lot of work, which is volume, which is regression in some sense, and certainly complexity, as in terms of fairly complex scenarios, complex features, complex attributes, and so on. So to handle a certain degree of complexity and certain power, I want to go back and recollect the notion of grasshopper. I may possess a lot of power, but if I'm able to slowly pull it back and think about it and apply it, and then I leave it, I get the power of a catapult. So it is not that the power that I have as an individual is any less. In fact, it's probably significantly more than any of the tools. And today's world, we have obviously, intelligence tools like AI-driven tools, which augment my intellectual power too. So we've got power from technology, we've got power from intellectual tools. So the intent of this, in a way, the musing is to kind of set a certain degree of sharp focus on the power of practice and the importance of process in whatever form, in addition to technology that come along, so that we can actually do meaningful high performance QA that is sustainable. Because high performance is not about a cyclist speeding for about 5 kilometers and then, dropping flat because he's exhausted all his energy. If you go back and look at some of these, cyclists or any other discipline, sustenance is terribly important. So can you generate the power consistently for many, many, many hours? And that's why you will find, if you watch Tour de France, which is going to happen shortly now, you will find those guys ride about 200 kilometers reasonably non-stop, generating an immense amount of power, being able to complete it in about 5 to 6 hours, which is a phenomenon. Try doing that. We might be able to ride a 40-kilometer speed maybe for a few minutes, and after that, I think our tongue will pop out. And sustenance, therefore, is important, and that makes a terrible amount of difference, in delivering fantastic performance. And therefore, it's just not about tools and technology that matters. It is significantly the context of the process and practice, and individual practice matters heck of a lot.